All right, Ladyada, what is this?
Okay, so this is a really interesting project I'm doing right now. This is a Metro Mini, so it's an Arduino compatible. This is a little sensor, and I purposely am picking a sensor that's not particularly complicated. This is the OPT 4048, and this is a tri-stimulus color sensor. It's basically a light color sensor. And what I'm doing is I'm experimenting with this new LLM technology that just came out called Claude Code. And Claude Code is like, I've used Claude a bunch of times. It's an LLM where you have a window and you type back and forth, or use the API, and you use like a whatever, some GUI. And sometimes you can use stuff like Cursor where it's embedded in your editor. But I've never really liked the embedded editor part of Cursor. I really like to kind of work with my files. And also, something that's very interesting about Claude Code is it gives you shell access to the LLM, which, like, I think if I told myself 2 years about this, they'd be like, this is incredibly stupid. Why would you give this like crazy AI access to your shell? But you know what? Like, we're living in amazing times. So the fact that I can tell Claude now how to run shell commands means I can have it automatically compile code for Arduino compatibles with the Arduino CLI, and then upload the code and then check the output and fix the code. So I have like a full debugging cycle where I'm like, I'm like driving the car, but I have this copilot that's like telling me where to go. So we do it together. I'll show you how it works through the command line tool. It's kind of like a weird cross between like IRC and like a BBS or whatever, and also using like CMake. But just to show you, so this hardware is connected to my computer, like I said, Arduino compatible, and it's got this little sensor connected over I2C. So now let's go to the computer. So like I said, if you want to install Claude Code, I think it's out of preview mode, so you can install it. I'm running Windows. I will say, just like, I'll have some hints up later, but basically, if you're running Windows 10, you need to be running Windows 11 to do hardware interaction, because you'll get through like the Claude installation, and then you'll realize you have no way to access the USB device. And you have to access the USB device using USB IPD, which is the WSL, that's Windows Subsystem Linux, way of getting hardware that would normally be here. It's not appearing here because I've bound it into WSL. Now you're probably like, why am I using WSL? Because Claude Code doesn't run on Windows native yet. So there's a lot of these like weird ass workarounds I'm doing just because it doesn't run on Windows natively yet. Why? I don't know. I'm sure they're working on it. I'm sure Claude and people who tend to Claude are like going back and forth. But it does work under WSL. I'm using Debian in this case. There's tutorials on how to do USB IPD, but basically, you have these, devices. And in this case, I've attached the Scilabs chip, which is the USB serial chip, COM port into Debian. And so in my Debian desktop here, I've got, let's make this nice and big. It shows up here. And then I've got TTY USB 0, right? I've got this, I've got access to the serial device through WSL, not through Windows proper. Okay, now you'll have to install like Arduino CLI, and you'll have to install some other tools, whatever. And like, I'm not going to go through all that. So the way I've kind of come up with this like workflow, and I'm using this, I'm just using Notion, which is like a way of like having text with easy way to copy and paste it, is I'm trying to come up with like prompts that I can kind of recycle and reuse. And one thing that's like, as I'm doing this is frustrating is, of course, like LLMs have this like randomness in it. So you running the same prompt over and over doesn't always get you the same output, but you can kind of sort of tweak the prompt until it gets really close. So one of the things I'm doing is, I'll show on my main screen, there's the data sheet, right? But the data sheet is massive, and also it's like weirdly formatted, and LLMs only work with text. So what we have to tell it to do, and I do this in the initial prompt, is I kind of give it some ideas of like how the style, blah, 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 and then convert the PDF into a text file. So for example, where's my thing? Okay, so here I've created, another thing I've done is I've separated the Arduino, like I've created a separate folder for like my Arduino work. So it doesn't touch like my main library folder. And in this folder, I created like a new library, opt 4048, and I have the PDF file. The PDF file is like the data sheet. So now you launch Claude after you've done the npm install, and it's like, hi, I'm here, I'm ready. And like I said, one thing I did, oh, by the way, you need an API key for this, and it's not super cheap. So just be where you're going to be burning API queries. But I kind of ran this over and over again until I feel like I got very close. So I'm kind of running this live. Hopefully it'll work. If it doesn't, I'll try to fix it. So I paste in, my prompts. And like I said, a lot of the prompt is just telling it like, please don't write all of the code at once, but it kind of does anyways because it's Claude 3.7. For everything you want to do, reading files, writing to files, diffs, etc., it'll tell you, like, for example, it wants to run this bash command. And I can tell it, you can run it this time. You can always run PDF to text. For now, I'll just say yes. And you can see it's kind of got this like nice curses, colorful boxes. I kind of feel like I'm like back in like the 90s. Okay, so now it's converted it. It reads the text. And what's interesting is I think that this is how like ChatGPT was reading PDFs, because I was like, I'd upload a PDF and I was like, how are you reading? Like, how are you parsing it? And I think it was just using PDF to text. So if not, I don't know, I'll find other tools. I don't know if converting it to Markdown would be any better. Okay, so what's nice is that it gives you a diff. And like my text is really big. Again, I think once they get this going, it'll be more integrated with an IDE. So what's nice is that it tells me like, okay, it has the Doxygen formats I've asked it for. I tell it to use bus.io. I tell it, okay, please just make that register map, like all of the registers in the data sheet, and give me a little information. And you start with just the instantiator and the begin. And then it says, do you want to make these edits? What's nice is that it doesn't make changes, even though it has write access to files in the directory. It doesn't automatically do it unless like I tell it. I was talking to someone who does a lot of like work with machine learning, and I was explaining how I use LLMs, and she was like, yeah, like because you do open source, you get to treat it differently because you're like, use all the history of my stuff. Okay, now it's going to write the CPP file. Ditto, it kind of copies my standard boilerplates, license text. The header, it does the I2C device delete create. You can pass in the wire, you can pass in a separate I2C address. In this case, what's interesting is I actually told it not to do this yet, but it did it. And I don't know if it's because I've run this prompt so many times that it's like been added to some history somewhere. But anyways, it creates the CPP file. So this is actually where I would like I've done this with Claude, and I've gone to here, and I would actually just copy it, like literally I'll just copy and paste all this text in it. Say, make the header, make the test. Here's the INO, that's the test example. It creates the object. It starts serial. I tell it I always want this baud rate, and then halt if you can't find it, and then do nothing else. So where it gets interesting is like, okay, now it's like, okay, I've created those files, and I saved them to the file system. Great. In this case, I already did this, but I'm just gonna copy. Like I said, it kind of skipped ahead. I told it like, don't write the test function, but it wrote the test function. Anyways, now what's cool is I've edited the prompts to now ask it, can you check if you've already done this? Because one thing I've noticed with Claude Code is it doesn't save your context at all. There's no way to, like, you can compact it and you can tell it to write to like a markdown file. But basically, every time you connect, like as usual with an LLM, it's like a totally fresh connection. Okay. Next up, that's where it gets interesting. We can actually tell it, okay, let's compile the code with Arduino CLI. I installed Arduino CLI, and I tell it, if you're having issues, use the verbose mode, but let's just try getting it compiling. Use the sketch. I've tried to make this generic so that I can reuse this prompt for other chips without having to like tweak and edit the prompt. Hopefully this is gonna work. Okay, cool. It was able to compile it. And you can see it does give you the output. And I think I told it like use verbose mode. Let's see, or it used verbose mode. I don't know, maybe I didn't ask it to. Why is it taking so long? I think the first time it compiles, it takes a while. Right? Get a little bit nervous when it's just sitting here for like 30 seconds. What are you doing? It says it compiled.
Actioning.
I think I'm going to just tell it to stop. Okay, it compiled. Now let's try uploading. I don't know, it kind of went, wait, hold on, that's there. Okay, so now I'm telling it to, like I said, every time you run it, it's like, it's not determinate, it's indeterminate. Okay, so it found the USB port because I tell it to run board list, so it finds the port. And then that's how it knows what my USB port's called. And then the first thing I do is actually, I don't upload the test sketch it wrote. I actually tell it to upload the I2C example from Adafruit testbed. And the reason I do that, you can see this was just blinking, is I wanted to verify the hardware connection and also just to verify like it can actually do the upload. Second, I wanted to get the serial output, right? Because I want to see like, did this work? So I use grab serial, you can use STTY, you can use like whatever, but the trick is, it's not, you need to tell it to like do a timeout or like it doesn't know how to quit things, I don't think. I think it only runs in non-interactive mode. So just make sure any bash commands you want it to run are non-interactive. So in this case, it tells you the output and I say, look for the I2C address 0x44, which it finds. And it's like, great, now I can continue with uploading the sketch. It uploads the sketch. And then now I'm going to tell it, check the output. And now this is what's getting interesting because like sometimes I run it. Oh yeah, it works. Sometimes it gets the bytes, the chip ID backwards, and it does eventually like, I didn't record it, but it got the byte order backwards. It thought it was like 0x2108 when it did the comparison. But then by reading the output, and I told it like, well, try to fix it based on what you see the I2C traffic is, it was able to say like, oh, I see what happened. Like I have to swap the bytes. So that's kind of neat. But that's how far I've gotten. So far. But I think this is like, the hardest part for me is getting the context started, because now I can just say like, okay, let's just go and do all the registers. And then for each register, like what I do is I have on my side monitor here, the data sheet, because I don't trust the LLMs. Like they do make mistakes, especially as the context gets started long and they start to like get confused. So what I do after, once I get like, okay, it started, I say like, okay, let's go through the register map and let's see, I can find where the register map is because this is like how to use it. Okay, so I say like, okay, add setters and getters for like, the register map, the exponent, and the LSB. Like it probably could do an okay job, but I found that so far, like because drivers are complicated, it works best if I sort of tell it like, okay, like go forward 5 steps, and then like let's test that, and then go forward another 5 steps. So the next thing I would do is probably, have like the operating mode, add getters for all of these like counters and stuff, and then eventually I'll tell it, okay, now convert this data into like the Lux or XYZ data and do the test. So I'm kind of interested. It's like I said, I've used Claude Code and Sonnet for hardware work before, but it's always been me just like doing this copy paste back and forth, a little delicately trying to make sure that especially as the context gets long, it can start rewriting the wrong things, trying to make sure that I'm getting everything in the right spot. What's neat also is there's a couple other extra things built in, which I haven't used yet, but I'm interested in. One is you can compact the conversation, and then another thing, and then you can also do cost. You can say, like how much.
How much does this cost?
60 cents.
This is not bad. It's like an arcade,
It's like,
it's like a token.
Two Pac-Man runs.
Inflation, man.
There's another thing I'll say. I can't quite figure out how to get there, but there was a way you can go up to look at previous commands, but there was a way to get to like the conversation and fork it off, but I don't remember how I got there. I have to like some like special command. But anyways, cool stuff. I think this is like the first time that
it's like
we've gotten automated
Claude,
hardware.
Let's take this one offline.
Yeah, it's like let's do hardware development fully. Like having that hardware workflow where it like does the coding and tests. And even like, I'll tell you, I wouldn't use it for like the high level thinking of how a driver should run, but like stuff like, oh, there's a compiler error, or like I forgot a typed out, if I didn't copy and paste something right, it'll fix little bugs like, oh, you know, I thought there was an underscore and there wasn't. It will see the compiler error and then it'll just fix it. So I think for library development, it's going to be kind of neat. Hardware development, you know, people have always asked me like, how come you can't do continuous integration with hardware? And I'm like, how would you have automated like upload and then look at the output and know what it meant? But I think, you know, we're getting close to it now. Anyways, check this out.
You know, I'm sure these techniques and more are in Apple and
they've got something. Yeah, no, they have something, but it's like, it doesn't make sense for
no one's
layman.
We'll never know. It's a secret sauce with so many things. So this is cool. This is like we're making advanced manufacturing in a unique way.
Yeah, so I'm going to
continue. 60 cents. For 60 cents.
I mean, it's a bar. I will say, you know, it's you are paying per token, so it's not going to be as cheap as the flat $20 fee. But like, if I can, you know, getting it to this point and then again continuing on with the driver, I'm going to try it out. I haven't actually I just got this working to the state where it's like, okay, I can consistently get it to upload code and check the output. And the next step is to do this, but like, I feel like I'm getting closer to having a like semi-automated way of doing driver development, which is like very tedious. And this will also be very interesting for CircuitPython and Python hardware development, you know, because again, like Claude is really good at Python.
They all are. So that's the neat thing. It's like almost a native language.
Yeah. Anyways, so that's
more later.
My desk.